Alright guys, so today we're just going to go over how to select the best Lewis structure for a molecule. This was on an old test. It was asking what's the best Lewis structure for N2H4, which is called hydrazine. So these are the structures they gave us, but your first step shouldn't even be to look at the structure. We're just going to find the total amount of valence electrons we should be expecting in a structure. So there's two nitrogens, so that's 2N. Nitrogen has 5 valence electrons, so we multiply that by 2, and we're going to add that with 4 because hydrogen has 1 valence electron and there's 4 hydrogens. So we're expecting 14 total electrons in our structure. And y'all should know how to count, but just in case, 2, 4, 6, 8, 10, 12. So we already know this is wrong. 2, 4, 6, 8, 10, 12, 14, that's fine. 2, 4, 6, 8, 10, 12, 14, that's fine. 2, 4, 6, 8, 10, 12, 14, that's fine. So now we're going to check to see if everything has its octet filled. So as we know, hydrogen has its octet filled if it has one bond out of it. So all the hydrogens are filled here, all the hydrogens are filled here, all the hydrogens are filled here. Nitrogen has its octet filled if it has 8 electrons, so we're looking for 4 bonds or 2 lone pairs. Like, let's just count it out. So for this one, we have 2, 4, 6, 8, 10. That could be okay. We'll check it again when we check for expanded octet. This nitrogen also has 10 on it. Let's look over here. 2, 4, 6, 8, that's fine. 2, 4, 6, 8, that's fine. Let's look over here. 2, 4, 6, 8, 2, 4, 6, 8. Those are all fine. So now we get to check for expanded octet. Nitrogen is in, I don't know if y'all can see this, is in the second row. So it cannot have an expanded octet. So here, when we were saying that there are 10 electrons around this nitrogen, this cannot happen. Nope, not okay, because it's not in row 3 or below. All right, so now we get to check formal charge. So formal charge is how many it brings to the deal. So let's just split up these bonds. This is how I do it, like so. Oops, sorry. All right. Okay, cool. So there is 1 electron around this hydrogen, and hydrogen only has 1 valence electron, so that's 1 minus 1 equals 0. So there's 0 charge on this one, 0 charge on this one, 0 charge on this one, 0 charge on this one. Cool. So now we get to count around the nitrogen. 1, 2, 3, 4, 5. 5. Nitrogen has 5 valence electrons. So that's 5 minus 5 equals 0. And then it's the same thing here. 5 minus 5 equals 0. So completely neutral structure. Awesome. All right, let's check over here. 1. So this hydrogen is 1 minus 1 equals 0. 0, 0, 0. Cool, that's great. 1, 2, 3, 4, 5, 6. So that's negative 1. Is it negative 1? Yes, because it's an extra hydrogen. It's an extra, it's an extra electron. And then here we have 1, 2, 3, 4. So that's 5 minus 4. That's a positive charge. So even though both of these structures are neutral, which is what we're looking for, this one has more formal charges, which means it is not the ideal or best Lewis structure in this case. So C is the right answer. Okay, sorry. I'm having some issues. C is the right answer. All right, cool. If you have any questions, comments, concerns, please let me know. I'm going to send this out in the email. And have a good weekend, guys.